Hey there guys, here we are working through some differentiation AS level maths exam questions involving stationary points. So I have enough for 2 videos. These are the more straightforward questions. The second video is going to be the harder, much bigger mark questions. So you want to try and make sure you can do them all. So, let's go. Okay then, first up, find the coordinates in terms of A of the minimum point on the graph y equals x squared minus 5x add A, where A is a constant. So, there's 2 ways we could do this, either completing the square or differentiation. Given the title of the video, we're going to use differentiation. So, at turning points, dy by dx equals 0. So the first thing we're going to do is differentiate. So, dy by dx is going to be 2x minus 5. Now, we should probably say at the minimum point dy by dx equals 0. So that then gives us 2x minus 5 equals 0. So x is 5 over 2. Now we need to find the y coordinate, so we sub that into the original equation. So y is 5 halves squared minus 5 lots of 5 halves add A, and that should give you minus 25 quarters add A. So the coordinates are 5 halves minus 25 quarters add A. Okay, number 2, curve C has equation y equals x squared minus 2x minus 24 root x. Part A, find the first and second derivatives. Okay, first of all, let's deal with the root x. So let's write that in power form. So y equals x squared minus 2x minus 24x to the half. Okay, so let's differentiate. So dy by dx is 2x minus 2 minus, so the half comes down, multiplies 24, so we have 12, and then x to the power minus 1 half. Okay, now we could write that as 2x minus 2 minus 12 over root x. Okay, now for the second derivative. We're going to get 2 Now, the negative 1/2 comes down and multiplies negative 12, so we get plus 6 x to the minus 3 halves. So that we can write as 2 add 6 over the square root of x cubed. Given part B wants us to verify that C has a stationary point when x equals 4. So we should say that at a stationary point dy by dx must equal 0. So we're going to test it with x equals 4. So we are going to get 2 times 4 minus 2, so 8 minus 2 minus 12 over root 4, so 12 over 2. So we have 8 minus 2 minus 6. That is indeed equal to 0. Given part C wants us to determine the nature of the stationary point, giving reason for our answer. So this is why they've asked for the second derivative. We need to find the value of the second derivative when x is 4. If it's greater than 0, then it's a minimum. If it's less than 0, then it's a maximum. So when x is 4, the second derivative is gonna be 2 add 6 over the square root of 4 cubed. So that's 2 add 6 over the square root of 64, so that's 8. So that's 2 add 3/4, which is 11/4. Now that is greater than 0. Therefore, the point is a minimum, and I've run out of room. Okay, number 3, pretty much an identical question except for the curve. So this time C is y equals 3x to the 4 minus 8x to the 3 minus 3. Part A, find the first and second derivatives. Alright, so dy by dx is 12x cubed minus 24x squared. Now our second derivative is then gonna be 36x squared minus 48x. Okay, then part B wants us to verify there is a stationary point when x equals 2. So again, we would want to say at a stationary point dy by dx must equal 0. Now, when x is 2, dy by dx is gonna be 12 times 8, which is 96, minus 24 times 4, which is also 96. Therefore, there is no stationary point when x is equal to 2. And then the final part again wants us to determine the nature of the stationary point, giving reason for our answer. So, let x equals 2 into the second derivative. And we are going to get 36 times 4, which is 144, minus 48 times 2, which is 96. Now that gives us 48, which is greater than 0. So again, we have a minimum. Okay, now the final question, this time y is 16x add 1 over x squared. First of all, find the first and second derivatives. So first of all, rewrite y. So y is 16x add x to the minus 2. Okay, so that means then dy by dx is gonna be 16 minus 2x to the minus 3. Now we can write that as 16 minus 2 over x cubed. And then the second derivative where the minus 3 comes down and multiplies to minus 2, so that's positive 6x to the minus 4. Which we can write as 6 over x to the 4. Okay then, to finish off, we now want to find the coordinates of the stationary point and determine its nature. So again, to get full marks, you would want to start by saying at a stationary point dy by dx is equal to 0. So we are going to set 16 minus 2 over x cubed equal to 0. Okay, now let's multiply through by x cubed. So we get 16x cubed minus 2 is equal to 0. Now I'm going to divide through by 2 and add 1 to both sides. So we're going to get 8x cubed is equal to 1. Divide by 8, and we get x cubed is 1/8. So x is the cube root of that, which is 1/2. Now it asked for the coordinates, so we also need the y coordinate. So when x is 1/2, y is 16 times a half, add 1/2 squared. So 16 times a half is 8. And then we have 1/1/4, so that's 4. So we have 8 add 4, that's 12. So the coordinates are 1/2, 12. Now, to determine the nature of the stationary point, we use the second derivative. So, when x is 1/2, the second derivative is gonna be six over 1/2 to the power 4. So 1/2 to the power 4 is 1/16. So that's going to give us 96. Now again, that's greater than 0. So we have a minimum. Okay then guys, that's it for this set. The next one in this playlist is gonna be harder stationary point questions. Hope to see you there. Take it easy. Take care.